Okay, so this video is going to focus on inverse trig functions. These are things like sine inverse or cosine inverse or tangent inverse. And in class we've mentioned that you use these inverse trig functions when you're trying to find an angle, but we didn't necessarily talk about why you do that. So that's what this video is hopefully going to explain. So far, we've been looking at the regular trig functions, right? Sine, cosine, tangent, and then three reciprocals, cosecant, secant, cotangent. And we're just going to work with sine for the purposes of this, just to keep everything consistent. But we know in general that the sine of some angle is equal to the opposite side of the triangle over the hypotenuse of the triangle. But really, this ratio is just a number. We've done a lot of, you need the exact value and yada, yada, yada. But usually when we're trying to work backwards to find an angle, we're using the calculator, which means we don't need an exact value. So we can rewrite this and just say sine of theta is equal to some number. Okay. Technically, that number has to be between 0 and 1. We haven't really gotten to that point in the unit yet, but every sine value will be a decimal. And that's also true for cosine. And in some of the problems that we've looked at with the calculator, you're given something very simple like theta, your angle is 59 degrees. Find the sine of theta. And that's a very straightforward problem. Okay, we take our equation, sine of theta is equal to a number. We plug in our angle. So the sine of 59 degrees is equal to some number. And the way that we find that number is to plug it into the calculator. Okay, sine of 59, making sure you're in degree mode, tells us that the number, sine of 59, is equal to 0.8572. Okay, and this would be the answer to our question. The sine of 59 is that number. Okay, but we've also seen some examples where you're given this number or you're given the ratio and you're asked to find out what angle that is related to or what angle that number came from. Okay, so we still have sine of theta equals some number, but perhaps instead of being given an angle, we're told that the number is equal to this. Or another way that it's usually written is the sine of theta is equal to 0.8572, and you're told or you're asked to find theta. So notice the difference. The first question, we're given an angle. We're asked to find a trig value. The second example, we are given a trig value. We're asked to find an angle. Okay, so the fact that we're doing the opposite of what we did for the last problem should hint to you that we need to use an inverse. So let's take our template here and plug in what we know. Sine, we don't know theta, that's what we're looking for, but we know that the sine of theta is equal to 0.8572. Okay, now we need to find theta. In order to get theta by itself, if you think about this in a very algebraic sort of way, when we want to get rid of sine, the opposite of sine, or what undoes a sine, is a sine inverse. So it's like we are taking the sine inverse of that side of the equation. And if you take the sine inverse of that side of the equation, you must also take the sine inverse of that side of the equation. Okay. So we have, let me just write this out here, and I'm going to erase this so I have some more room. We are at the point where we have the sine inverse of the sine of theta is equal to the sine inverse of 0.8572. Well, the sine inverse of the sine of theta is just theta. This is very much so similar to what we were doing with the logs and the exponents. When we had the ln of e of some number, the ln and the e undo each other. They go away. So that all we have left is the 3x. Very much so the same. The sine inverse of the sine. This is the composition of functions. Those go away and we're just left with theta. Okay, and then on the other side we still have sine inverse of 0.8572. Well, you can do this on your calculator. Again, most of you have to hit shift or second. So I would do second sine to get sine inverse, 0.8572. And that tells me that theta is 59 degrees. Again, if you were in radians, it would give you your angle measure in radians. So just check your mode and check whatever MATLAB is asking you for. But when we know the sine and we're looking for the angle, we must use the sine inverse. Okay. We're going to do one other example just to kind of highlight that point. Okay. Example. Cosine of theta equals 4/5. Okay, so that's the information we're given, and we are asked to find theta to the nearest degree. Okay, so cosine of theta equals 4/5. If I want to get theta by itself, if I want to undo a cosine, I use the cosine inverse. So I take the cosine inverse of both sides. I take the cosine inverse of this side as well. Cosine inverse of the cosine is just theta. Cosine inverse of 4/5. Right? And then this I can plug into the calculator. In class so far when we've done this, I've kind of skipped over this entire step, this idea of taking the sine inverse or the cosine inverse or the tangent inverse of both sides, but in reality that's what we are doing. Okay, and then I can take the cosine inverse of 4/5 and find that my theta to the nearest degree is going to be 37 degrees. Okay, so you should try that with your calculator. I'm also going to do it in radians just so you can see the difference. I still type exactly the same thing into my calculator, cosine inverse of 4/5, but in radians I get 0.6435 radians. Okay. These are the same angle, just one of them is in degrees and one of them is in radians. Okay. So now that we've seen this idea of taking the sine inverse of both sides, or taking the secant inverse of both sides, whatever your trig function happens to be, right? In general, using an inverse trig function tells you theta. So, to summarize that big idea from before, if you are looking for theta, and you know a trig value, use inverse trig. Okay. So that's the big idea with that. And there are some problems on MATLAB for you to practice with that.